So let's go over your homework from last night. On page 155, they give you two problems, and I asked you to give me the two half reactions. So this would have been one of the half reactions. And since the electrons are on the product side, this is oxidation. And this should have been your reduction half reaction. And this is what you should have gotten for number 6. So if you go to the science website and click on Unit 10, there is a link for a chart. And this is a chart of standard reduction potentials. You heard about these in the video that you watched last night. So what you want to do is look at the reactions for number 5 and find them on this chart. So you're literally going to be looking for copper and copper plus 2, or zinc plus 2 going to zinc. The thing that you have to remember is that what you're looking at on that chart is a standard reduction potential. So when you have an oxidation reaction like you do in this part right here, you're not going to find it written the way we have it. You're going to find it written backwards. So go ahead and find those on that chart. So when I look at the chart, I find what I just wrote in red. It was the second one from the top on the second column. Since the second reaction is actually a reduction reaction, you're going to be able to find that reaction just as we have it written on the chart. It was in the second column also, about 2/3 of the way down. And for that one, you get the E value to be 0.76 volts. So the formula that you're going to need to memorize is this one right here. And what we're going to be doing is we're going to be adding together these electromotive forces to figure out if a reaction would be spontaneous or not. Spontaneous means it's going to happen on its own. So you're going to go back and you're going to look at your reactions. And this one, since it's the reduction, you took it straight off the chart, and that's the correct number, that number that I have in red. When you're looking at this reaction, what you should notice is it's the complete flip of the one that we found on the chart. So remember, this is what we found on the chart, but we need it for the actual reaction that we have. So what we're going to do, since we have this value for that reaction, and the one that we need is just the complete opposite of that one, we just completely flipped it, we're going to switch the sign of that E value. So for the reaction the way I have it written, the E value is going to be negative 0.34 volts. So then you're going to plug it into the formula. And remember, it's reduction plus the oxidation. So I have negative 0.76 volts, that's the one that we got off the chart, plus a negative 0.34 volts, because remember we had to switch the signs because we had to make it into an oxidation reaction. And so when I add this together, I get a negative 1.10 volts. And what this tells me is because of this negative sign, I know that this reaction is not spontaneous, and in order for this to happen, you would have to have a battery to force the electrons to move. Let's go over a couple of terms that you read about and that you talked about yesterday when you went over the questions that had to go with your reading. So when you're having these cells, you will be able to label, you can draw pictures of how these look, and you can label parts of the diagram. So reduction happens at a place that we called the cathode, and the oxidation happens at a place that we call the anode. You need to keep those straight in your head. So I don't know if you remember yesterday, but I gave you two mnemonic devices, an-ox, and then the other one was red cat. And so an-ox or red cat helps you figure out which ones go together. Okay? So let's look at reaction number 6. Can you please label for me which reaction's happening at the cathode and which one is happening at the anode? So just write the word cathode or anode next to where that would be happening. So this is what you should have gotten if you labeled it correctly. So these charts of standard reduction potentials There are lots of different charts. Some are longer than others just because they include more reactions. So for number 6, the reaction, I couldn't find it on the chart that I gave you, so I went and looked it up. So this number right here came off of a standard reduction potential chart that looked just like this one, except it was twice as long. So then find the other reaction that we have for question number 6. You should have found that it was negative 0.14 volts for the tin plus 2 to tin metal reaction. So then you want to find out what Ecell is. So write down your formula and then plug in your values. So when you add them together, you get a positive 0.01 volts. So since this value is positive, we know that this reaction is spontaneous. And I know spontaneous isn't quite going to make any sense to you just yet. When I get to school on Thursday, I will do a demo for you and show you what this actually means. So just go with the rules. If Ecell is negative, then it's not spontaneous. If Ecell is positive, it's spontaneous, and we will talk more about it when I get back in class. Okay, so go back in your book and look at page 151. You should have already written the 2 balanced half reactions for these. We're going to go back and we're going to add this Ecell step to redox problems. So what I want you to do is look at number 6, look at your 2 half reactions, find them on the chart, and then figure out if Ecell is positive or negative, and then tell me if you think that this is a spontaneous reaction or not. Okay, so be super careful when you're looking at that chart. There were several that had iron in them, but you want the one that has +2 ion on one side and +3 ion on the other. Okay, so I wrote down the values that I took off of the chart, and I wrote this subscript here to remind me that those were reduction potentials. So what I have to remember is which one is my oxidation, because I'm going to have to flip the sign. So if you have them labeled like this, it's going to be super easy. That tells you that since this is the reduction reaction, then this value is good the way that you have it written. Since this is an oxidation reaction, you actually need E oxidation. And so remember, all you have to do is flip the sign. And so when you add those together, you get a positive 0.56 volts, and therefore you know that this is spontaneous. Okay, so let's try page 152, number 9. Again, you should have already separated this one and written half reactions. So now I just want you to do the part where you're going to find the E values for each reaction and then find me Ecell and then tell me if it's spontaneous or not. So pause the screencast, work it out, and then play it along and I'll talk you through it. So I took my 2 half reactions and I wrote down the values that I found off of the chart that had those parts in them. This one is my reduction half reaction, so I'm going to leave that number as is. This is my oxidation half reaction, so I'm going to have to flip the sign of that E value. So remember, to find E of cell, you're just going to add the 2 values together. And when you add them together, you get a positive 1.14 volts, so therefore, yes, it is going to be a spontaneous reaction. Okay, let's do one more. Page 152, number 8. Again, you should already have the half reactions written out. Look for them on the chart, find the E values for each reaction, and then solve for the Ecell and tell me if it's spontaneous or not. Remember, pause the screencast. I'll work it through with you and walk you through it. Alright, so when I go to... So these are the values that you find off of the chart. Then you have to figure out which one's my oxidation reaction because I know I have to flip the sign of that value. And so once you label your half reactions, you know that you have to flip the value of the aluminum reaction. And so when you solve it out, you get a total Ecell value of positive 2.99 volts. And so therefore this one is spontaneous. Okay, so let's finish going over your homework. This is page 155, part E. So you have an electrochemical cell, and they tell you what the reactions are. When you're drawing an electrochemical cell, what I have, and remember, I'm not an artist, but what I have is a basic skeleton of what every electrochemical cell is going to look like. And then you have to fill in all the parts. So I wrote down the two reactions. I separated it into the two half reactions, which you should have already done also. And then I labeled my electrodes. These are my electrodes. And so then remember, you can label your electrodes as a cathode or an anode, but it depends on which reaction is happening where. So remember, red, cat. So find where is reduction happening, because that's my cathode. So you should have picked that to be the cathode because the silver ion is gaining an electron to become silver metal. So then by default, then this one better be the anode where oxidation is happening. So then what you also need to remember is that the electrons then are getting lost here, and so they are going to travel along the wire. We'll register it. This is my voltmeter. And the electrons flow through the wire, and then silver can pick it up and then become silver metal. In these things, excuse me, these are solutions. So it would be something like copper 2 and silver nitrate, but those are soluble, so we know that they're going to separate into their ions, and so that's why we write their ions. In these cases, if you think about when you did your lab, the nitrate ion would have been the spectator ion that doesn't show up for us in the half reactions. Alright, so remember, this is your salt bridge, and its job is just to keep the solutions electrically neutral so that the electrons are going to want to flow. And this is your wire. It connects the two electrodes, and it's just a pathway for the electrons to move through the reaction. But the key here is that we pass it through a voltmeter so that we can actually register how many volts are passing through when this is doing work. Okay, so then the last part that you have to do is figure out your E values. So you need to go to the chart and find these two things, and then figure out if this is spontaneous or not. So off the chart, you get these values, and then remember, you have to figure out where oxidation is happening because you have to flip the sign. Remember, your mnemonic is an-ox, so oxidation happens at the anode, so you have to flip the sign of that one. And so when you add them together, you get an Ecell value of positive 0.46 volts. So since it's positive, this reaction is spontaneous. So your homework for tonight is to go back to page 154, and you have already done 1, 2, 3, 4. You did where you wrote the half reactions. So now I want you to go back and look up the E reduction values and solve for Ecell and tell me whether or not it's spontaneous. So just for those 4 on page 154. There are 2 values. Remember I said that the chart that I'm giving you access to is just the most common ones. There's actually some really, really long lists of standard reduction potentials. So 2 of them that you're going to need I've listed below. Alright, I will see you guys tomorrow. Remember, email me if you have questions.